Hello, my name is Antonio Ereditato. I'm the spokesperson of the Opera collaboration. Opera is a sort of global enterprise. It's three big groups. We have Italians from INFN and different Italian universities. Then we have a Japanese group around the Nagoya group. And there are a few other groups from Europe, and particularly from France, from Germany, from Switzerland, and I'm from University of Bern.
Neutrinos are elementary particles. They do not have electric charge, and they interact very weakly with matter, with so-called weak interactions, and they are capable of passing the entire Earth without interacting. Neutrinos have been, in the last 30 years, unveiling many interesting features in particle physics. At the beginning, we thought that the neutrinos didn't have a mass, and it has been with the observation of the flux of neutrinos coming from the sun that the people have been starting to think that neutrinos could have a mass, and that they could change nature during their travel path. They could transform themselves in between three different types of neutrinos, which are the electron neutrino, the muon neutrino, and the tau neutrino. Neutrinos are also linked to many aspects of cosmology, to the birth of the universe. They may be related to the asymmetry between matter and antimatter in the universe, and they are also the most common particles in the universe. So the interesting aspect of this measurement was a combination between techniques used in high-energy physics for neutrino detections, the high-energy beam which is sent to Gran Sasso, which has the unique property in the world to provide a very high rate of neutrino interactions that we can detect in our Opera detector. And this is related to the fact that this neutrino beam is a high-energy neutrino beam. And then the other very interesting aspect was to combine all this with metrology techniques. So techniques related to the measurement of the space and the time, which are commonly used in other fields, but they were never used in particle physics at this level of accuracy. Well, we were very surprised. We were expecting, we did all this analysis in a blind way. We were expecting to find negative results, indeed. And then we were very surprised to detect this anticipation of neutrinos with respect to what you could compute, assuming the light on the same travel path. So the effect that we measured is equivalent to 60 nanoseconds over a time of flight of 2.4 milliseconds, or if you want to express it in terms of distance, it's an anticipation of 20 meters over 730 kilometers. So the Minos experiment in 2007 published a paper with a result which is similar to our result, but it is not accurate enough to be considered as a real result. It could be also compatible with the negative result. Deliberately, we have chosen not to interpret our results in terms of new physics. If this result is confirmed, then of course it will have some deep implications in terms of new physics. We are just presenting today our result as experimentalists.
As far as we are concerned today, this is a sort of side measurement, side analysis. Since Opera detects neutrinos rather well, we are also able to make some precision measurements, in particular the measurement of the speed of neutrinos from CERN to Gran Sasso. Well, the result, actually, got us astonished because we didn't expect to find such an anomaly. The anomaly is that it seems from our measurement that the neutrino goes a little faster than light, and this is somehow 20 parts per million, which may look like a tiny effect, but it's according to the sensitivity of our measurement, it's a rather precise measurement. You know, we would like to be very prudent at the moment. We would like just to say that we made a measurement, this measurement is accurate, and therefore we would leave to the entire community, which is actually the goal of this seminar today, such a way that the whole community could tell us give us interpretations or suggestions, and certainly one thing which is fundamental, redo the experiment in different conditions, different groups, different people, and hopefully to find the same result.